All right, so we have another set of factoring, and this is required doing the method called difference of squares. So let's pick a problem. For example, easy one is this one. Let's go with the easy one. Let's say x squared minus 36. It's called a perfect square. Why? Because 36 is a perfect square, first of all, right? That's going to be factored out into like saying 6 squared. And you see that it's going to be x squared minus 6 squared. And it's called difference of squares. The difference of square. Why? Because it's difference of these two squares. This one and this one, 6 squared and x squared, right? And then when you factor this out, it's going to be what? X minus 6 times x plus 6. So in foiling, back then when you were doing foiling, let's do the foiling and see why we get that. When you're doing foiling, you multiply, distribute each one of these into the binomial, like that. You get 4 terms, right? X times x is x squared. X times positive is plus 6x. Negative 6 times x is negative 6x. Negative 6 times positive 6 is negative 36. See, these two cancel. 0. So you get x squared minus 36. So now we go opposite. That was foiling. Now, so when you have this, you can write that. Okay, that's what we did. So that was easier one. Now a little bit harder than this. If you get like this, you have 3n squared minus 75. Do you see a perfect square here? I don't, right? I don't. That's why we need to go with the first thing that we did earlier today with the videos. So these videos are going to be posted on our website and our YouTube. So what we did was we need to look for the factoring, common factor to factor. What is common factor here between, pick the numbers between 3 and 75. Is there anything? Yes, 3 is the common factor, right? Factor 3. So divide 3n squared divided by 3 is what? Just n squared. 75 divided by 3 is 25 with negative sign, because negative divided by positive is negative. Now what we have, yes, now it's a perfect square. N squared minus 5 squared. Maggie says it's a perfect square. So that's 3. So that's 3, and this becomes what? N minus 5 times n plus 5. There you go. That's a factor. That was kind of easier one. Let's do another one, a little bit harder one. Which, yeah, so my student wants to give me a hard time. It's the hardest one. So 294 r squared minus 150. All right, Maggie, I'll remember that. So what is common factor between 294 and 150? And I want to know if there's something in factor, but I know the tricks. So if this is a perfect square, if this is a different, if I can use difference of squares, I need to get something here like perfect square, like 1, 4, 9, 16, 25, and then 36, and then 49, and then just like that, 64, and then 91, right? 81, right? So you do one of these. And if you look carefully, this can go, 25 can go in 150, right? So I can tell that is 6 times 25. 6 times 25 is 150. I want to examine and see if 6 is factorable. If it is, then I'm going to get 25 over here. That's tricky. So let's use that trick. So now I want to see if this is divisible by 6. If it is, I can convert that into the difference of squares. So let's see 294. Let me tell you something I probably don't know. What is the rule for 294? Is 294 divisible by 6? If we want to know a number is divisible by 6, there are two things that needs to apply. One, the number must be divisible by 2. That number needs to be divisible by 3 also. Both of these. Is this divisible by 2? Yes, because this is even. First, ones place is even. Any number that has a ones place of an even number and 0, that's divisible by 2. 2, is this divisible by 3? The rule for 3 is you add this digit, 2, 9, 4. 2 plus 9 plus 4. If you add them, you get 15. 15 is divisible by 3, therefore this 294 is divisible by 3. So I examine that. I know now 294 is divisible by 6. Then what? I'm gonna factor 6 because it's divisible by 6. And I should get a perfect square. So 294 divided by 6. So 6 times 4 is 24. Maggie says 49. Let's see. 54, right? And then 6 times 9, 54. Awesome. So 49, right? R squared is left there. Minus 150 divided by 6 is 25, right? We're there. Now we got it. So A keyboard. So please. So 6. Now what I'm going to have here. Let me show it to you like this. I'll go step by step. That's 7R, all of that to the second power, right? Minus 5 to the second power. Cool. You see that? It's a difference of squares. So it's going to be 6 times these two. Binomial. 7R minus 5, 7R plus 5. And then we're done. So we factor it out. One more of these so that you have enough. Anyone? This one. So again, another one, another good one. So we have this 64x to the 6th minus y to the 6th. If you want to know, we can use difference of squares for this. So first of all, 64, if you divide it, 64 is what? 8 times 8, right? And what is 8? It's 2 times 2 times 2, 2, 2, 2, 6 twos. If you multiply, you get 64, 2 to the power of 6, right? So that's 2 to the power of 6, x to the power of 6, minus y to the power of 6. And then that's same as 2x, all of that to the 6th power, minus y to the 6th power. How would I write this into perfect square? Remember, previous problems here. Always when you do perfect square, power is dividing by 2. So this power is divided by 2. Originally it was 2, became 1. This was 2, became 1. But we do that, we divide the power by 2. So that's the trick. So same thing we do here. So we can divide it by 2. It's going to be this. 2x, all of that to the 3rd power. Since I'm using that, I'm going to make this bracket. Or make it nice. Like that bracket. That's going to be 2x to the 3rd minus y to the 3rd. That's going to be 2x, all of that to the 3rd. Again, bracket here. Two x to the 3rd plus y to the 3rd. So when you have higher power like this, you just have to divide the power by 2. So I can make one harder one, really very harder one, harder than this one, much harder than this one. So then you see how we divide the power. Let's say you have an example. You have this one, y to the 8 minus x to the 8. See, this can be factored a couple of times. So every time you're going to divide the power by 2. It's going to be y to the 4th, x to the 4th, subtracted, and y to the 4th plus x to the 4th, right? See, that's a difference of squares. So it's factors like this. And if you look carefully, this again can be factored, right? So that's going to be what? This by itself, it's going to be y squared minus x squared, right? Times y squared plus x squared. And this just stays because we cannot factor this. It's not difference, it's sum, and we don't have formula for that. And if you look carefully again, this can be factored. Oops. A keyword, I'm going to disable you forever. So that's the one, right? So what we get, y minus x times y plus x. And the rest just drops down here. Y squared plus x squared times y to the fourth plus x to the fourth. See, that's what it is over there. So we're done with this one.